In this video, I'd like to look at simulating dice in Wolfram Cloud or Mathematica. The first thing is to understand the difference between RandomSample and RandomChoice, and the differences in does it allow duplications or not. So RandomSample does not allow duplications. So here I am picking taking a sample of numbers between 1 and 6. I'm grabbing 4 of them, and I'll do Shift Enter. And I got 6, 3, 4, 2. I got 4, 2, 1, 3. But we're never seeing any duplications here. We're never getting 5 twice or anything like that. Whereas here in RandomChoice, again, similar. Choosing between 1 and 6 and choosing 4 of them, but now duplications are allowed. And we see there I got 2 3s. I have 2 1s. But I can get them all different, but I can also allow duplications. So when I'm simulating dice, I'm going to roll a number of dice, then it's possible, of course, for the dice to come up the same. So I want RandomChoice versus RandomSample. And we saw how this worked here, what the notation is. We have what we're picking from. The semicolon gives me sort of all the things in between. So from 1 to 6, and I'm picking 4 of them. And it gives me a list. What I can do here is, instead of just picking a number that I want, I can get a sort of a 2-dimensional list of these simulated die values. Okay, so I am going to get, I'm going to think of it as getting 100 samples of rolling 3 dice. So I'm going to get 100 triples. So let's run this. And there they are. So I get a 163 was a triple. I rolled 3 dice, and then on my second sample, I got a 214. Okay. Now what I want to do with each sample is get the total. So there's a built-in method for totaling. And I want to total within a triple. So it's like a two-dimensional thing. I've got sort of a list of lists or a 2-dimensional array, and I can make a total in different directions. And here I'm saying that I want this 2, this curly bracket 2, is going to give me the sum within triples. So if I could do a 1 or just allow it to do its default thing, and that would sum in sort of a different direction. But this is the one I want for here. I want to sum within the triple. So I'm going to add the 1, the 6, and the 3 and get a 10. I haven't run this yet for this. I've run it previously, but I haven't run it this time. So don't look at the sums until we've run it. Okay. And so there is the 10. The 1, the 6, and the 3 were added to get 10. The 2, the 1, the 4 were added to get 7. The 3, the 5, and the 6 were added to get 14, etc. So now I have, and I named this the same way I named the results of using RandomChoice. I named it dice. So this single equal is just sort of assigning, giving something a name. So I called this result dice, and then I made a total of dice and called it summed. And it also is, so I could call this, I could refer to this as summed. I can also refer to it as out 8. Trying to get in the habit of naming things. And I can get, now I have a list. I can do all sorts of statistical measures on the list. I'm going to make a histogram of these results. And there it is. Now, for some reason, I got a lot of 7s for, I don't know what reason, just randomly. I mean, I expect to get more in the middle, but this one ended up to be particularly high. 16s. There were no 16s for whatever reason, but such is the nature of random stuff. Okay, I could run it all again and I'd get a different answer. And one of the statistical measures I'll look at is the kurtosis. So first I'm going to do it without this numerical stuff and see what it gives me. It gives me, does some like exact calculation. That is the sort of nature of Mathematica, to do something exactly if it can, but that doesn't have a lot of meaning for me in this case. So I'm going to get it numerically, and I'll say I want 4 significant digits or something. So shift enter, and there I'm getting a 2.384. And I think that the kurtosis, if this were some Gaussian distribution, then this version of kurtosis would give me a 3, I believe, and I'd have to do 2 things to sort of get to a Gaussian. I would need more samples and more dice. 3 is not enough. But as I increase the number of dice, the samples just gives me better randomness, and then the increased number of dice moves me towards, if it were just 1 dice, it would be a uniform distribution, and it moves, increasing the number of dice moves me from a uniform distribution to a normal distribution, to a bell curve. Okay, that's what I wanted to show you. The main thing, random sample versus random choice. For this thing, random choice was the appropriate choice. How to get sort of a 2-dimensional array of these things, and how to add within that 2-dimensional array and get back to a sort of simple list, and then various statistical measures, of which these are just 2. All right, that's what I wanted to show you. Thanks much for your attention.